Welcome back everyone to the sessions on basics of engineering products. So in the last class we have seen the different electric heating techniques, that is resistance heating and induction heating. Accordingly, the different types we have seen each device application also, that is nothing but resistance heating, which uses is nothing but electric geyser and immersion heater, whereas induction stove uses the principle of induction heating. The next concept is light. So in this light, your electrical energy is being converted to light, Suppose the best example is nothing but your tube lights or CFL, sodium vapor lamps, LEDs. So we are nothing but simply supplying them with the electrical energy, and in return we are getting the light. So how are we converting this? What is the principle being used for this conversion? Let's see that. So light, what is the basically light? So light is defined as the electromagnetic radiation which is very much capable of affecting the sense of sight. So light is defined as the electromagnetic radiation which is capable of affecting the sense of sight. So lightning is the application of light. So it is being deliberate use of light to produce a practical effect. So in this we started on, initially we started on light evolved with the evolution of candle in the year 1800 by the ancient Egyptians. We started on with in the year 1800 with the candle. After that, in 1810, oil gas lamp was introduced, which uses the oil, and accordingly we will be getting that lamp or light will be getting it. So it was known as oil gas lamp. After a long time, in 1879, by Thomas Alva Edison, we got the incandescent lamp. So incandescent lamp everyone knows, I think you would have seen in your childhood. So this filament will be getting some electrical energy, and the same principle as similar to your resistance heating, the power is being dissipated in the form of heat. But after a certain temperature, that heat will be able to emit light also. So that principle we have used it for the incandescent lamp. So it mainly works on the principle of incandescence. The next one is the fluorescent tube light. So after a long time, by checking that the intensity, the efficiency of the incandescent light was not sufficient, and it is mainly converting that electrical energy to heat rather than light. The efficiency was less, so we moved on to the fluorescent tube light. Again, to increase the efficiency of the tube light, we moved on to the compact fluorescent lamps, which we are using in nowadays, nothing but the CFLs. The last one, presently we are using for the LED lamps. So LED lamps we are mainly using for most of the time because it is very much efficient with respect to the energy consumption. So let's see the different this one, incandescent, fluorescent, CFL, sodium vapor, mercury vapor, these lamps, what is the working principle behind them? Let's see now. So we will be starting on with the incandescent. So it works on the principle of incandescence. So what is incandescence? It is the emission of electromagnetic radiations from a hot body. This hotness is due to the result of it increase in temperature. So whenever your temperature is being increased, the body will release some electromagnetic radiations. That radiations causes the emission of light. So that principle, this whole principle we are calling it as incandescence. So it is the emission of electromagnetic radiation from a hot body as a result of increase in temperature. So here you can see that in your welding shops or anything, if you are heating this one, so due to the result of increase in temperature, you can see that light is being emitted. So this is clearly the principle. The same principle we are using in the incandescent lamp also. So this filament which is being present in the lamp will be heated up. As a result of increase of its temperature, it will emit some electromagnetic radiations. It will emit some electromagnetic radiations. So which will help in the light. So this electromagnetic radiations which will be visible to us as light. So it is being exploited, it is being used in incandescent light bulbs. So on checking the energy consumption, suppose you are feeding 100% of electrical energy, most 70% of it goes in the form of IR radiations. 70% of the energy fed is being shifted to the IR radiations, means infrared radiations. The next 20% is being dissipated in the form of heat. It is being dissipated in the form of heat by that is nothing but by conduction or convection. If you remember, in your childhood you would have seen that whenever the incandescent bulb was on for a longer period of time, and after that if you want to touch the surface of the glass bulb, it was hot. So nothing but it was due to this 20% of heat. And only 10% is visible in the form of light. Only 10% is visible in the form of light. So the efficiency, overall efficiency of energy is nothing but 10%. We are giving 100%, but we are getting only the 10%. So which is a major drawback. But how to overcome it, we will be seeing it next. Let's first check out the incandescent lamp. So we will be getting only 10% is being converted into light. So it has been much less efficient, and the initial cost is also very small when compared to the other, but it has a lot of disadvantages as the conversion efficiency is very less. So it mainly works on the principle of incandescence. So whenever the filament is very much heated up, it will be, because of the increase of its temperature, it will be emitting some electromagnetic radiations which is being visible to us as light. So it works on the principle of, so it is an electric light which is being produced when a filament is heated to a high temperature. Due to this heat of high temperature, it will be releasing some electromagnetic radiations which is visible to us as light. So this is the filament which is being heated up. So this filament is being heated up, and after a certain temperature it will be emitting some radiations which is visible to us as light. So the typical temperature, usually the filament used is tungsten filament. Usually the filament used is tungsten filament, and the typical temperature limit is 2000 kelvins to 3300 kelvins. 2000 kelvins to 3300 kelvin. So for the filament to emit the light, the temperature should be in the range of that much well. So most of the energy is being consumed in the form of heat. Whatever the energy we are providing, it is being consumed in the form of heat. So to protect this hot filament from oxidation, we are using some inert gases also, such as argon, nitrogen, krypton or xenon. So as to prevent this tungsten filament from oxidation, we are moving on for the inert gases such as argon, nitrogen, krypton or xenon. So this filament is being heated up. So this one, usually it is being filled with, this glass tube is filled with the inert gases so as to protect this tungsten filament from oxidation. So as mentioned, the efficiency of the fluorescent incandescent lamp is nothing but the 10%. But what is the final output? We need light or heat, but we need light, right? So the fluorescent bulbs have come into picture as the efficiency is only 10% for the incandescent one. So it produces less heat when compared to that of incandescent. So the same contribution we can see here is if you are supplying 100% of energy, 100% of energy, the infrared radiations have now decreased to 30%. So initially it was 70% in case of incandescent, now it has come to 30%. The next is 45% is by heat in form of loss by conduction or convection, and your visible radiations has now increased to 25%. The visible radiation has now increased to 25%. So 30, 45 and 25. So it has increased from 10 to 25%, we have increased the visible light. So let's see. So it is more efficient, as we can see that initially it was 10%, now it has become 25%. So it is more efficient when compared to incandescent. So there are various types which you would have seen. This is nothing but we call it as tube lights, and this is nothing but the CFLs, the compact fluorescent lamps. The compact fluorescent lamps. Both of them use the same principle. So let's see what is the principle of working principle of fluorescent lamps. So usually fluorescent lamp consists of a sealed glass tube, which contains the mercury liquid droplets, of mercury liquid. Why mercury is being used, you will be able to know in the working principle in a clear way. So apart from the mercury liquids, to prevent it from oxidation, we will be going for the inert gases also, which is being kept at, the condition is it should be under low pressure. The inert gases should be kept under low pressure. So the tube consists of two electrodes and the inner surface, like suppose if your tube light is there, so this inner surface is being coated by phosphorus powder. The inner surface is coated by phosphorus powder. So the tube has usually two electrodes and the inner surface is coated by phosphorus powder. So you can see here, so this tube will be painted with the phosphorus powder at the inside, and it will be containing the mercury liquid droplets as well as the any inert gas. Mainly will be going for argon, which is kept under low pressure, and it will having a ballast. The purpose of ballast you will be getting to know now. So let's see what happens is, so these are the electrodes present. These are the electrodes present. Whenever your electric current is passing through it, this heating element and all will get heated up. So it heats up the filament. So these electrodes will be now heating up the filament. So what happens is, from this metal surface, the electrons will boil off. So electrons will be getting some energy and it will be having that energy. What happens is, these hot electrons, present. So here we have a inert gas, argon or neon kept under low pressure. So due to this it will be interacting with this inert gas. So it will ionize the inert gas. So these electrons, after ionizing the inert gas, and we have a mercury liquid droplets. So these electrons will be ionizing the inert gas. In addition to it, it will be converting these mercury liquid droplets to gas. So high energy of electrons will be converting the liquid droplets to gas, and after that it will be colliding with each other. The ions and electrons will be colliding with the mercury droplets, and it will be converting all of them to gases. So that mercury, the electrons will be jumping from one band to the another band. So it will be releasing the ultraviolet radiations. It will be releasing the ultraviolet radiations. But the disadvantage is the ultraviolet radiations are not at all visible to the human light. The ultraviolet radiations are not at all visible to the human light. So they need to be converted to the visible light. For this purpose, the inner surface was coated with the phosphorus. So for the next step, so this ultraviolet light is not visible to the human eye. So hence, whenever it interacts with the phosphorus powder, so these ultraviolet radiations will be converted to visible light. It will be converted to visible light. So the main basic principle can be written as, so we can write it as, so first the electrodes will be getting the current, which will be releasing the electrons, from the heating element. After releasing the electrons, because of the high energy of electrons, it will be ionizing the inert gas. It will be ionizing the inert gas. Now these inert gases will convert mercury liquid to gas. So now these electrons will release UV radiations. But these UV radiations are not at all visible. Hence, by phosphorus powder, it will be converted to visible light. So the first process in the working principle of fluorescent lamp is the electrodes will be passing through the current, so which gets heated up and will release the electrons. These high energy of electrons will ionize the inert gas, and this inert gas will be gaining some energy and it will be converting those mercury liquid droplets to gases. These gases and all with the high energy will be releasing some UV radiations, but as UV radiations are not at all visible to human eye, it will be converted to visible light by the inner coating of this phosphorus powder placed inside the glass tube. So the main purpose of glass tube in phosphorus coating is to convert that UV radiations to visible light. So that is the principle of fluorescent lamp. Now next let's see the mercury vapor lamps. So mercury vapor lamps is similar to the fluorescent one, just the only principle is you will be using directly the mercury vapor. So the mercury vapor is being filled inside a glass tube with the mercury vapor and with the two electrodes. So these two electrodes will be now heating, and those electrodes will be releasing the electrons, which will be like converting that mercury vapor, and it will be releasing that light. So whenever your current is being passed through, as mentioned, mercury vapor is ionized and it will be forming a arc. So that arc will be emitting light in the UV region. So for again that conversion, so this glass bulb will be filled with the mercury vapor. So whenever current is being passed, it will be getting ionized, you will be getting that arc which will be emitting that UV region. So to convert that into visible light, it should be coated with the fluorescent material as we have seen for the fluorescent lamp. So the life of this one is very high, and it is almost all about 100 years. That's why it has found its application in societies, lighting streets, factories and large areas during the night time. So it has a larger life and it will be getting the good one. So this is an image of mercury vapor lamp in a street lighting. in a street lighting. Next is similar to the mercury vapor lamp, we have another one is nothing but the sodium vapor lamp. So it's also a gas discharge lamp which uses sodium vapor in an excited state. So it is being it uses the sodium vapor in an excited state, and apart from it we'll be using the inert gases also to produce light. So usually we'll be going for high pressure or low pressure sodium. We'll be going for high pressure or low pressure sodium. So it's an image of sodium vapor lamp, or we also call it as SP lamp. So what happens is neon gas will start discharging. In addition to it, you will be getting the pink light. After this process, after this one, the electron starts charging and it is taken over by sodium. So initially the process starts with the neon gas, but after some time, as high pressure or low pressure sodium is kept, after a particular 3 to 4 minutes span of time, your sodium will take place, and due to the increase of pressure, the light is now converted from pink to yellow. Pink to yellow. So it takes a span time of 3 to 4 minutes. So you can see here that, so this arc will initially be in pink in range by the neon gas. After that, here the whatever the sodium is being kept, that will take place and it converts that pink to yellow. It will convert the pink to yellow. So next, what is LED? You will already know that a LED. So what is LED? It's a light emitting diode. It's a light emitting diode. So it's nothing but a diode which emits light. Then what is a diode? For before moving to that, we all know the materials as we have conductors, insulators, and another one is semiconductors, which is between both these conductors and insulators. So semiconductors is nothing but a material which has conductivity in between semiconductors and insulators. So these semiconductors are being classified into two. They are intrinsic and extrinsic. Intrinsic and extrinsic. So the pure semiconductors are known as intrinsic, whereas extrinsic are the impure one. So on adding impurity to the intrinsic semiconductor, we will be getting extrinsic semiconductor, and that process we are calling it as doping. That process we are calling it as doping. So depending on the type of impurity added, extrinsic semiconductors have been classified into two types, that is P type and N type. So N type we are obtained by pentavalent impurity, whereas P type is obtained by trivalent impurity. P type is obtained by trivalent impurity. So this will have holes as majority, whereas N type have electrons as majority. So this is the basic classification. Semiconductors have been classified into two types, intrinsic and extrinsic. Intrinsic is the purest form, extrinsic is the impure form. Depending on the type of impurity added, it has been another class, again classified as P type and N type. P type is obtained by the addition of trivalent, whereas N type is obtained by the addition of pentavalent. N type semiconductors have electrons as majority, whereas P type have holes as majority. So let's see what is a diode. So diode is nothing but a combination of P and N type semiconductor. So it's a combination of P type and N type semiconductor. So it can be applied voltage in two ways, that is forward bias and reverse bias. So depending on the voltage potentials, if P is connected to positive and N to negative, it is said to be forward biased. So as P have holes as majority, this has electrons. So they will be repelled, and it starts moving towards this junction. So that will result in a current. So this this knowledge is being required. So let's see. So what is a LED? So as mentioned, LED is nothing but a light emitting diode. So it consists of a semiconductors which has been doped with impurities to create that PN junction diode. So we will be having a anode as well as a cathode, so which will be emitting light whenever the voltage is being applied. So before to that, let's see. So LEDs converts electrical energy to light energy, electrical energy to light energy. So the symbol of it is, the simple diode is represented by this one, as it is emitting light. So this is the symbol for the light emitting diode, also known as LED. So the different parts is, so it's a simple diode, so it will be emitting light. So how it is emitting light? We are again using the principle of your fluorescence only. So the three parts are plastic case, terminal pins, and the main one is diode. So this diode will be releasing something which is being converted into light. So the working is, we can see that as already mentioned, N type will have electrons, whereas P type will have holes. P type will have holes. So with the voltage potential, we will be getting some light. So how it is being connected? So as mentioned, this PN junction, it is being forward biased when P is connected to positive and N to negative. So the holes present in it and the electrons present in it will be getting repelled by the battery terminals and will move towards the junction. So as mentioned, these will be moving towards the junction. So this junction, whenever they are moving towards it, will be releasing the current, and that way you will be getting light. So this principle we are calling it as electroluminescence. Electroluminescence. So these electrons and holes will recombine with each other, and that will be emitting light in that process, which we are calling it as electroluminescence. So electrical energy is converted to light energy. Electrical energy is being converted to light energy. So because of the recombination of electrons and holes, we are getting light. So LEDs are available in different colors. So they are, some of them to be mentioned are red, orange, amber, yellow, green, blue and white. Compared to the remaining one, blue and white are usually the costly ones. So as you can see, this is the wavelength of it. So violet needs a 3.17, blue 2.73, green 2.52, yellow 2.15, orange 2.08 and red 1.62. So usually the color of LED depends on the semiconductor material, but it's a myth that it usually depends on the plastic body. No, it usually depends on the semiconductor material. Depending on the doping intensity, the color will be varying. So the wavelength is very much dependent on the band energy gap. So depending on the doping of the semiconductor material, the color intensity varies, but not on the plastic body. So LED color is mainly dependent on the semiconductor material, but not on the plastic body. So it has been used in most of the applications as cell phone, computers, traffic lights, architectural lighting, exit signs, motorcycles and bicycle lightings, traffic signals we are using it, railroad crossing signals in railway stations, in the display units we are using it, flashlights, emergency vehicle lightings. LEDs we can find in a various number of applications. Movement sensors, backlighting, LCDs we are using now, televisions we are using it, Christmas lightings, they are being used in many of the toys also. So LEDs are being finding a various applications because of its energy efficiency and the cost. The cost is very much less and the efficiency is very high when compared to the others. So on comparing one, to conclude it, we have studied all these lamps. So on comparing in one, we can see that incandescent will give us a efficacy of, means for wattage, per wattage it can give us a 10 to 30 lumens only. But the lifetime is also very less, it is only about 1000 to 3000. When coming for the fluorescent, it is 50 to 105 and the life is 10,000 to 45,000 hours. Coming for the CFL, the efficacy is 50 to 65 and the life is 20,000. Sodium vapor 80 to 140 and lifetime is 18,000 to 24,000 hours. Mercury vapor 30 to 60 and the lifetime is 24,000 to 1,75,000 hours. The last one coming to LED, we have a wide range, right from 4.5 to 150. 4.5 to 150, the lifetime is 40,000 to 1 lakh. So here on checking out one, you can see that these can be used for various applications. So 4.5 can be used for some and 150 can be used for some. And the lifetime is also very high when compared to the others. So in this way, LEDs are being finding a large number of applications. So to conclude the session, we have defined the light as emission of, it is an electromagnetic radiation that is capable of affecting the sense of sight. So we have seen the incandescent lamp. So incandescent lamp uses the principle of incandescence. So what is incandescence? As a result of increase in temperature, the hot body will be releasing some electromagnetic radiations. So we will be getting that light because of the heat. The next one is fluorescent lamp. For fluorescent lamp, we are using the electrodes which will be heated up and will be releasing electrons from the heating element. These electrons will be ionizing the inert gases and will be converting the mercury liquid droplets into gases. And these this high electrons will be releasing the UV radiations. But UV radiations is not visible to human eye, so it will be converted to visible light by the coating of phosphorus which is being coated inside the glass tube. Another one is sodium vapor and mercury vapor. So sodium vapor uses the neon gas which will be first taking up. It will be emitting pink light and after that some span of 3 to 4 minutes this sodium vapor will be taking into come and it will be converting that pink light to yellow light. Mercury vapor uses the mercury droplet, so it will be ionizing and converting the visible light. And the last one is LED, so which uses the principle of electroluminescence. The generation and recombination of holes and electrons will result in the emission of light. So to conclude it, we can say that LED has better efficacy and efficiency and has a larger lifetime when compared to other applications. So for most of the applications, we are now moving on to the LED. In the next class, we will be seeing the motors. So how are we using the principle of conversion of this electrical energy to mechanical energy? Thank you.